bridge, and that's been cut off and sent in by the dentist. That's going to be replaced. And one thing, just briefly look at the connector size between the pontic and the abutment there. That's going to come into play, but that did not break. The dentist cut through the connection between the pontic and the mesial abutment, but you look at that, and that's pretty tiny what you see going on there, and that's definitely one of the benefits of metal. As you probably heard me say, I haven't done a single unit PFM since 2009, since we've had Bruxer, but PFM bridges I still have a use for because of the fact that you can make these connectors as small as you can because of the strength of metal. So even though we can take a single unit of Bruxer and hammer it into a piece of wood, when it comes to a bridge and a connector, that's a different story. So I don't do single unit PFMs anymore, but metal bridges still do it. So let's take a look at what we got sent from the dentist, a nice, conscientious, wonderful dentist who sent us a full arch lower impression for this 3-unit bridge. One of the contraindications of a double arch tray is, in fact, a 3-unit bridge. So sending in a full arch impression like that's fantastic, and a full arch upper to go with it with a separate bite registration. That's absolutely wonderful. And when we pour up this case and take a look at it, things look pretty good. We've got some really nice preps there when we look at those 2 teeth. Those are pretty close to ideal, just examining those 2 preparations. And of course, the question we always have as a laboratory is, what does our occlusal reduction look like? And so we'll take a look here. I'll lift the pin just to make sure that's not interfering at all. And see, here's the challenge. Well, let's pretend it's a real patient. We're kind of looking at it from this angle, probably pulling the cheek back and trying to get a look. That's kind of our best case look that we'd ever get. Maybe we get the patient to turn a little this way, but it's hard to do. And this is one of the reasons why I love a depth cut based preparation sequence, because you always know exactly where you are. So the dentist finished these preparations and sent them in to us. If we look at just the solid model for a second, we'll notice it's probably just a little easier to see here without the upper one, that when we look at it from the side, we've got a little bit, not really a huge bump of soft tissue here, but we can see that our mesial margin and our distal margin on the bite are both below that. So any bridge framework is going to have to come up and over that tissue. There hasn't been any recontouring done here to that tissue. Again, wonderful impression, wonderful preparations. But any bridge work is going to have to come up and over this soft tissue here, which might get you thinking, I wonder if zirconia is going to be able to handle that. I wonder if the dentist could have gone and removed some of that tissue. Probably could have. But let's take a look. Gone are the days of just having to try to visually assess what's going on and figure it out. This is one of the huge benefits of CAD/CAM. And so basically what happens is when you send in these 2 impressions to us, the upper and lower models get poured, and then they get scanned and then articulated with the bite. And so now all of a sudden we're able to bring it into the digital realm. And this is where things really get interesting for us, because it's no more about guessing. We can try in our virtual bridge and see what it would look like, what the proper anatomy would be as we put it into place, the 2 abutments and the pontic, and say, okay, these are designs from our library. Obviously, when I got into dentistry 26 years ago, there wasn't a lot of times where you would have technicians necessarily carve, anatomy like this for you, especially on abutment teeth. You'd have to give them enough room to be able to do it, and you'd probably have to pay a lot of money too. And you can see, some of the less featured teeth. The resolution's a little lower over there, but you can see the designs that get pulled from the library now pretty much have ideal anatomy on them. And then we can see areas where we're going to have contact with the opposing teeth. And let's take a look now and see what we have in terms of vertical height. We mentioned the rule of 27 in the open, and if you'll recall what the rule of 27 is, that's the rule that says on a 3-unit bridge that's going to be fabricated from zirconia that we need to have 27 square millimeters as our connector between the pontic and either of the abutments, and it's the height squared times the width. So essentially we're looking at something that would be 3 millimeters high, which would be 9, 3 squared is 9, times 3 millimeters wide across this way, and that would be our 27 square millimeters. And as long as we have 27 square millimeters, 3 millimeters across and 3 vertically as well, or you can fudge it a little bit. If it's 2.6 millimeters vertically, you can make it slightly wider. buccolingually and still have the appropriate strength. You can't flatten it all the way. You can't vertically have 1 millimeter and then have 27 millimeters wide. That's not going to work. But you can play around with it a little bit. And so as we look here, we're going to notice that between, this is from 19 to 21, so we're going to see here that, or actually I should say 18 to 20, it got written up incorrectly on the lab slip. But you can see that between the bicuspid and the first molar, the height is 1.65 millimeters. Now, we'd like that to be 3 millimeters, but this takes into consideration the tissue that's there, where we have to come up and over this tissue to get to this ponic. So 1.65 is pretty narrow vertically. That's not, that's at the boundary of not being sufficient. We'll go back a tooth, and between the ponic and the distal abutment, we have 1.63 millimeters. So that means that we're going to have to make it much wider than we ordinarily would if we had 3 millimeters here. And when we start to look at the width of this, we can see that we've got 2 millimeters. We're not even really getting to 3 millimeters between the bicuspid and the pontic, and we're at 2.66 between the pontic and the molar here. And so to take this out to 4 millimeters, where it would need to be to support that decrease in the vertical height of the connector, obviously it's just going to be a block of teeth there, and not very, not hygienically acceptable, a bad periodontal situation, and bad aesthetically, even though it's in the posterior. So that's starting to look like we're definitely not going to be able to do a Bruxer bridge, full contour zirconia bridge there. Let's look at some reduction here. As we look right through the bicuspid area, you can see where this slice is taken. So the three-dimensional model has a 2D cross section. And you can see from the preparation out to the opposing tooth, we have 1.21 millimeters. That's plenty for Bruxer. We prefer 1 millimeter as the ideal thickness of Bruxer, but anything above that, like 1.2, is even better. If you've seen the hammer test where we hit that crown and it goes into the piece of wood, that's actually 1.5 millimeters if you want to try to achieve that strength. We often say the minimum thickness of Bruxer is 0.6 millimeters, and it is, but that's really not desirable. We always want to go more than that if we can, just because it allows you to make any adjustments that you need to make. In fact, while I'm talking about that, if you look at what this doctor's done in terms of margins, you'll see some nice chamfer margins on both of these preparations. We'll also often say that Bruxer can tolerate a feather edge margin much like cast gold, and that's true, but that doesn't mean it's preferred. It will handle it, but you're always going to be better off having something a little bit thicker like this, because milling zirconia to a feather edge can get a little bit dicey, and so there is a tendency to leave it a little bit thicker so it doesn't chip and break at any point, either when they're finishing it after it's been sintered or when it's in the mouth. So even though it can handle a feather edge when necessary, a chamfer margin is preferable. Kind of like even though Bruxer can handle 0.6 millimeters, 1.0 is more ideal, and 1.2 is even better. And we can look on the molar as well. And as we look at the molar, just mesial to the midpoint right along here, you can see we have 0.72 millimeters, 0.72 millimeters. So we're getting pretty close to that 0.6, to that minimum thickness. This will work, but there's going to need to be a note to the doctor letting him know that if anything needs to be adjusted, if the bite happens to be high here because of the temporary bridge or whatever, this opposing tooth is going to need to be adjusted, and not whatever material is down here, if in fact it's going to be something along the lines of a zirconia material, because Bruxer does not want to be less than 0.6 of a millimeter. So that's just mesial to the midpoint of that tooth. And if we go just distal to that, we'll see that we have 0.95 millimeters. So there we're doing a little better. We're closer to, much closer to, in fact, almost right on that 1.0 millimeters. That's an ideal thickness for Bruxer. Of course, like I said, Bruxer likes it even thicker than that. All the way to 2 millimeters, it just continues to gain strength. The strength for zirconia really drops off at around 0.6 of a millimeter, which is why we consider that the minimal. So when you look at this, we've got 0.72 and we've got 0.95. Let's glance again just at the models and see if we can see that. I don't know. Can you? It's difficult to tell. Oftentimes, we can cheat in the laboratory and look from the lingual side and go, oh yeah, that is a little close. And it's the lingual cusp of that upper tooth. It always is. I always tell dentists, what I do is if I'm just going to place a couple depth cuts, it's going to be in the central groove and on the two lingual cusp tips, because those are always the one on these posterior teeth that cause the problem. So just to the mesial of that's where we have the 0.72, and just distal to that's where we have that 0.95 millimeters where we're going to be okay. So in terms of occlusal reduction, we actually have enough thickness on both of those teeth. There's our 1.2 millimeter on the bicuspid that we have, and that's going to be fine too. So in terms of occlusal reduction, we actually have enough room to do the bruxer, but in terms of having a bridge and the proper rule of 27 square millimeter connector size between the abutments and the pontic, we do not have it. And so even though the occlusal clearance is there for the bruxer bridge, because of the fact that the rule of 27 would be violated, we're not able to do that. And thus, we called the dentist and let him know that a PFM bridge is going to be the way to go here. There's not going to be a way to predictably have a zirconia bridge here that will not fracture, and it will fracture at those kind of dimensions. It's simply not going to be able to work. And so for this dentist and for this patient, a PFM bridge is going to have to be redone. Not a bad looking PFM bridge. Does it look as good as bruxer? Maybe not, but as you can see, the doctor prepared enough for us so that we don't really have any metal margin showing anywhere on the bridge. And so hopefully the patient will be happy with the result, even though they weren't able to do the bruxer. And when the bridge goes into place, you can see now, in fact, we have room to come up and over that tissue. And of course, we have room on the occlusal as well. They didn't even have to do a metal occlusal there. And again, it brings me back to that original bridge when we looked at that originally. And I just kind of mentioned that right off the bat. And that is, you can see how small that connector is from the occlusal to the gingival on that PFM bridge. So do not throw, PFMs away yet. Certainly not for multiple unit restorations like this, because it still plays a very valuable role. There's simply only two choices here. It's a PFM bridge or a cast gold bridge. The only two materials that are strong enough, or any kind of cast metal, that are strong enough to have a small enough connector to get up and over that tissue and still be able to connect the pontic and abutment with enough strength not to break. I mean, I've only seen one metal framework break, I think, in about 26 years of dentistry. If this were a bruxer bridge, or I should say, if this were a bruxer bridge, that's pretty much a guaranteed fracture. I don't know when, if it's 2 weeks, 2 months, 2 years, but it will break, because before we were aware of that rule, we sent out a lot of bridges like this in zirconia, and they did in fact break. And so if you get a call from us about that, you'll know why. We don't want it to break, the patient doesn't want it to break, and if it violates the rule of 20